Here's how to create a contour area toolpath, or better known as a surfacing toolpath. So we can go up to Create Operation, and for this example, we will surface this chamfer that is around our circular pocket. If we go to the mill contour type, we can select Contour Area. We'll go ahead and use a quarter ball end mill. Since we're going to be surfacing, I like to use a tool that has a corner radius rather than a sharp end mill. We'll go ahead and say OK here, and then we are in our Contour Area or Area Mill dialog box. This is a very, very common toolpath that I use every day and many times throughout a part to surface features or cut features. So the first example will be to surface. We can say specify cut area and click our chamfer. That is what we want to cut. We'll say OK. Then we can go into our cutting parameters. Here you'll see your non-steep and steep cutting options. You can also see down here that there's an extend option. We'll go ahead and use a 15,000 step over for our non-steep area, and then it's also a good habit to make your steep cutting areas match for your distance or your Z-level depth of cut in your steep. The difference, when NX looks at the feature, if it determines that the feature is steep, it will use the Z-level zigzag, Z-level zig, or Z-level zigzag with lifts or Z-level helical options. If it determines it is a non-steep cutting feature based on your tool axis angle, it will use one of the non-steep cutting patterns. It is possible that there may be an instance where it uses both. You might have a wall that is drafted and then a corner radius, and the corner radius may be non-steep and the wall is steep, resulting in both of these cutting parameter patterns being used on your part. That's why it's a good habit to make your max distance in non-steep and your Z-level depth per cut the same exact number, so your step over is applied equally no matter what feature. Once you have this set, we can go ahead and just say OK, and then we will generate this toolpath. Here you will see that if I display my toolpath, I have a surfacing toolpath that just goes circularly around this chamfer. Go ahead and I'll drag this up under my roughing toolpath, and we will watch this guy surface the chamfer. And there it is. You have a nice evenly surfaced chamfer. Another way to use contour area is to finish flat faces. It doesn't only have to be used for surfacing. If I copy my contour area toolpath and paste another option below, we'll open that up and we're going to change our tool to be a flat end mill, and we're going to cut this flat face that has the 4 holes piercing through it. Again, if we specify our cut area as this flat face, we can say OK. Then once again, go back to our cutting parameters, and we can now change this to maybe be 100,000ths of an inch. Because it's going to be a flat face cutting with a flat end mill, the bottom of the tool is parallel to the face, so we know that we can use a larger step over. We will, for this example to begin, turn off extended edges, and we'll say OK, and go ahead and generate that toolpath. Here you'll see that it has a much bigger step over cutting this flat face, but it dips around and avoids these holes. If we verify this, and then just play it really quickly, you'll see that there are these little tangs of material left in the holes. If I were to come in with a spot drill or center drill after this, it would hit that tang and deflect the center drill and put my hole off of location. To avoid this, we can open the contour area, turn back on that extended edges, and then use anywhere from 20 to 55% of the tool to extend that toolpath and make sure that we fill those holes. By changing that to 55 and saying OK, when we generate this, you'll see that it now makes an even cut step over those holes and extends out over it. This will also extend at all edges, so you can see the outer periphery is overhung now as well, whereas before it was right even with the line. The third option for using a contour area is it can be used multi-axisly, even though it is just a 3D toolpath. If you copy it again, we can paste it, and we'll go back to using our quarter ball end mill to surface a chamfer. We can take this toolpath and we can select one of these side edges right here. We'll go ahead and say OK, and then we want to cut this from the front. We can go to our tool axis, specify our vector, and then select an inferred vector coming from this face. Remember, inferred vectors will come from the inferred center of that face, whatever you select. So you can see we're going to come in from the front now. We'll go to our cutting parameters, and we will double check this. 15 thousandths is good for our step over. I'm okay with having a little bit of an extend to make sure it overlaps those edges, and we'll say OK. If we generate that toolpath, you'll see now that we just surfaced this side. And here's a good example of using the steep and non-steep methods in this toolpath. Coming square onto the part, you will see that the top is a different pattern than the bottom, transitioning right here where you have these green lines. The top is our non-steep follow periphery cut pattern, and this bottom, where it overlaps, changed to steep with the zig. And the reason for that is NX looked at this feature and said the radius is non-steep to that tool axis. But when it extends down and goes down this sidewall a little bit, that is 90 degrees to the tool axis, which is a steep angle, so it's switched to the Z-level zig pattern. If we verify this, I'm sorry, you will see that the pattern will change. So right now we're going back and forth. Now we're going around and around on the actual chamfer, or I'm sorry, radius feature. So that is 3 different ways that you can manipulate a contour area toolpath.